The pneumatic system sources are engine bleed air, A.P.U. bleed air, or an external pneumatic source. The pneumatic system supplies regulated bleed air to the engine starter, the anti-ice system, the environmental control system, and for water pressurization. The main sources of bleed air for the pneumatic system are the engines. Various power settings cause changes in pressure and temperature output, which have to be regulated. To accomplish this regulation, bleed air is taken from two different compressor stages: low pressure port at stage number 5 and high pressure port at stage number 9. A low pressure check valve prevents reverse flow of high pressure bleed air into the engine low pressure supply port. The high stage bleed valve regulates bleed air pressure at low power settings, and the engine bleed valve regulates bleed air pressure at high power settings. The temperature is regulated to a predetermined value by a pre-cooler, which cools hot bleed air by fan and on ground, or ram air or fan air in flight conditions. With the engine bleed air buttons pushed in, the AMS controller automatically controls engine bleed air. If the engine bleed button is pushed out, engine bleed air is manually closed and a white bar will illuminate. The A.P.U. is capable of supplying constant bleed air to the pneumatic system on ground or in flight, but it is used primarily as a ground pneumatic source for the environmental control system and for engine starting. The A.P.U. bleed air duct is connected to the left-hand bleed air manifold with a check valve to prevent engine bleed air from flowing to the A.P.U. when the engine is running. The A.P.U. bleed valve controls A.P.U. bleed airflow to the pneumatic system. With the A.P.U. bleed button pushed in, the AMS controller automatically controls the valve through the A.P.U. FADEC. If the A.P.U. bleed button is pushed out, the A.P.U. FADEC will close it and the bar illuminates. To meet ground air supply needs, a dedicated engine start ground cart connection and an air conditioning ground cart connection are installed. The check valves installed at each port prevent air from backflowing. The two ground connection ports are located on the lower section of the fairing area of the airplane. An overheat detection system monitors the pneumatic system for hot air leaks. The system is comprised of dual overheat sensor loops, which provide signals to the air management system controller. This provides rapid and reliable overheat and leak detection for all parts of the bleed air distribution system. If an overheat sensor loop indicates a failure in its duct zone, the AMS shuts down the respective bleed system. A message is sent to the ICAS, and an amber bar illuminates on the applicable bleed button. The normal operation of the pneumatic system is automatic, and two independent networks provide complete segregation for pneumatic fault isolation. The left engine normally provides bleed air to the left bleed manifold, and the right engine normally provides bleed air to the right bleed manifold. Each manifold supplies a dedicated ECS pack and the on-side anti-ice system. If more than one bleed air source is available, the AMS logic uses the following priority. 1. On-side engine. 2. Opposite engine. 3. A.P.U. on ground with engine low power setting. Note that A.P.U. bleed air cannot be used for the anti-ice system operation in flight. In case of an engine bleed air source failure, the cross-bleed valve enables connection between the networks. In this case, the respective ECS pack and anti-ice system will be supplied from the opposite bleed source. This is normal for engine starting operation. AMS automation. AMS controller functional logic provides automatic control of engine bleed, A.P.U. bleed, ECS packs, and smoke detection according to the airplane's operation and condition. The engine bleed valve receives an electrical command to open when the following conditions occur simultaneously. Respective bleed switch is set to auto. Respective engine bleed is available. No fire is detected in the respective engine. No bleed duct leak is detected. The A.P.U. bleed valve receives an electrical command to open when the following conditions occur simultaneously. A.P.U. switch is set to auto. A.P.U. bleed is available. No A.P.U. and left bleed duct leak. Left engine bleed is unavailable. Anti-ice system not requested, or anti-ice system requested on, and anti-ice system is failed. A.P.U. bleed source prioritization. When the engine and A.P.U. bleed are available simultaneously, the AMS controller will prioritize A.P.U. bleed air when the following conditions are simultaneously met. Engine bleed pressure is below the minimum for engine start. The airplane is on ground. Ground speed is below 50 knots. Altitude is lower than 15,000 feet. A.P.U. bleed is available. The cross-bleed valve is operating normally. The cross-bleed is commanded open if cross-bleed switch is pushed in, auto, and any of the following conditions are met. One side provides manifold pressure and there is not a bleed air source on the opposite side. A.P.U. bleed button pushed out for main engine start. Engine number 2 start in the air. A.P.U. bleed off for engine number 1 start in the air. Pack 1 and Pack 2 shall be closed if any of the following conditions occur. A bleed air source is not available for the pack. The respective pack switch is off. Any engine is starting and the airplane is on the ground. Any engine is starting and A.P.U. is the bleed source. Respective bleed system duct leak. Flight deck pack, built-in test shutdown failures are present. ICAS message displayed. ECS selected off on the MCDU and ECS can be commanded off according to system logic. The ECS packs close during takeoff if any of the following conditions occur. Thrust levers set to max position. TDS reference AI set to all on the MCDU. TDS reference ECS set to off on the MCDU and A.P.U. bleed not available. The ECS packs are recovered if thrust levers are set to max position and any of the following conditions occur. Thrust lever reduction. The airplane is 500 feet above takeoff field altitude for takeoff with 2 engines operating. The airplane is above 9,700 feet for takeoff fields at 8,000 feet or below and one engine inoperative. The airplane is above 15,000 feet for takeoff fields above 8,000 feet and one engine inoperative. The smoke detector mounted in the recirculation bay will command both recirculation fans to off when smoke is detected in the recirculation bay. When smoke is detected on airplanes equipped with optional forward cargo compartment ventilation system, fan operation is terminated. The check valve closes by mechanical springs. The cargo outflow shutoff valve is commanded closed by AMS controller when smoke is detected in the forward cargo compartment.